Hello everyone, very good evening and welcome to the BYJU'S exam prep, the most comprehensive app for all competitive exams. Now guys, are you ready to solve questions from GATE paper 2002, 2008 and 2016? Then definitely there will be one question. Then why sir? Because the GATE 2024 will be conducted by what? That is already conducted by what? IISc Bangalore. And these papers were conducted by what? IISc Bangalore in 2002, 2008 and 2016. So when we are solving the question, we can get the idea about the pattern and what is the nature of question, and it will boost your confidence guys. Okay, so are you ready to solve the questions? Just I am going to solve questions from what? Network or circuit theory. So we have the questions from electronics branch as well as questions from what? Electrical branch. So stay tuned with me, subscribe the channel and like the session. But before starting the session, let me know that sound quality, picture quality, everything is fine. Yes, please. Okay, I think now everything is fine here. Okay. Now guys, this is a series where we are trying to cover all the questions from these 3 years, 2002, 2008 and 2016, right? So this is a series. Okay, now Padlu Yadav, Ashish Kumar, Jitendra, RDK Technologies. So what about your preparation? Is going well? Because now we have around 150 days for GATE examination. So I think everything is going fine. Remember, this is the part 1, and then after that we will discuss what? Part 2 also. Right, so where we will cover the remaining portion of the subject. So before starting the session, this is my introduction. Myself Sanjay Rathi. I am having 22 years of teaching experience, and these are my ranks in engineering services exam AIR 16, in ESE 2008 AIR 21, and I have trained more than 1 lakh students for these competitive exams. Right, तो डेली आपका ये इंट्रोडक्शन होता है ताकि आपको कॉन्फिडेंस आए. You can also crack this exam with what? Top rank, right? So you have to make the proper strategy for next 150 days guys. Then so this is my Telegram channel, Electronics by Sanjay Rathi. If you want the PDF of this class, right, then you can join now by Electronics by Sanjay Rathi on Telegram, where I will upload the PDF of this session with complete details, and for daily dose to improve your concept, for daily important question, latest information about the exam, notification about the class, PDF and notes. And if you have any doubts, then for answer for those doubts, you can join my Telegram channel, that is Electronics by Sanjay Rathi. And how many students you have cleared the engineering services mains examination? If you have cleared mains examination, then yes, share your result and get free mock interview with our expert panel. So UPSC Engineering Services 2023 mains results out. Share your results now on this platform. Then guys, I am taking the classes, regular classes on of what app? So you can download the BYJU'S exam prep app. Now I have taken 2 important sessions, 50 plus 20 plus 10 plus 5 formula for GATE 2024, and then what? Roadmap for next 150 days. If you have proper strategy, then okay. If you want some idea how to crack this examination, then that is the 2 session for you, right? And you can also download the PDF, and already I have taken the session on what? Control system. So you can join, and these 2 sessions are important for all 4 branches, whether it is mechanical, civil, electrical or electronics. Okay. Then, so that is, but these lectures are available on BYJU'S exam prep app. You can download app now. And guys, if you want to start your journey with us, take a step towards success in GATE by giving what? Scholarship test. So DJ scholarship test, right? Right. तो आप जब scholarship test दे रहे हैं, तो yes, this is the Asu sir is also the part of this previous year question series, Jitendra, right? So that is the question. You can avail what? 90% off on our program this Sunday 27th August 9 AM to 9 PM. First of all, give the scholarship test, right? Then if you want to know roadmap to be great topper in just 5 months, so you can join workshop by me, right, on 29th of August at 7:30 p.m. Please note this time and register for this workshop. That will be on our BYJU'S exam prep app. तो this window will be open for what 12 hours 9 a.m. to 9 p.m. तो इतना तो टाइम निकालिए संडे और एक बार जरूर टेस्ट दीजिएगा. You will get the idea about the questions, what about your weakness, what about your strength. और अगर आप इससे क्रैक करते हैं तो ये आपको 90% ऑफ भी मिलने वाला है. Okay. Now first of all I will start with the basics of the circuit theory. All type of questions, no, all type of questions. Basics of the circuit theory. Then what? Transient, two-port network, steady state analysis of sinusoidal signal, right? Each and every type of questions we are going to discuss here. Okay. Then first question on your screen, basics of circuit theory. So you have to use your copy, pen and calculator, virtual calculator, scribble pad, just like what exam. Okay, tell me what is the answer. First of all, the dependent current source shown in the figure, right? What is the answer options? MCQ. This is a MCQ. There will be 1/3 negative marking. Delivers 80 watt of power, absorb 80 watt of the power, delivers 40 watt of the power, absorb 40 watt of the power. Dependent source. Okay, quickly try to give me the answer. This is a voltage controlled current source. Voltage controlled current source. This is a dependent source. And this is independent source. What is the value of the V1? 20 volt. So this depends upon this independent source is 20. So V1 by 5. So 20 by 5 means what? 20 by 5 means it is directly we can say it is a 4 volt battery. It is a 4 volt, but it depends upon the value. If the user will change this value, this will automatically change. So this is the 20 divided by 5, that is the 4 volt. Now, what is the power deliver or absorb? Power deliver or absorb means what? You have to find the voltage at this point. What is the voltage across this? Let it is Vx. If you are going to get the Vx positive, that is the Vx positive. So current enter through the minus, leave the plus, means it will deliver the power. If suppose you are going to get the negative value, current enter through the plus, leave the minus, then what is this? It will absorb the power. So new students always remember these basic things. If the current enter through the plus, leave the minus, then that particular device will absorb the power. Absorb. Or if the current enter through the minus, leaving the plus, voltage, then this is called what? This particular device will deliver the power. So here we have to check. So I have given the polarity minus plus. So current enter through the minus, leaving the plus. Find the value of the Vx. Which answer is correct? Which one is correct here? Now, so how we can find that this is the Vx? Then Vx minus 20 divided by 5 plus Vx by 5. That is the Vx by 5 and that is nothing but what? 4. 20 by 5, that is the 4. What is the 4? Incoming. Now, this 5 LCM you can take 2Vx minus 20 is equal to 20. Then 2Vx is equal to 40. So what is the Vx is equal to 20 volt. Vx is equal to 20 volt. Positive value. Positive means it will deliver the power. Positive means it will deliver the power. So what is the power delivered? What is the value of the current? 4. What is the value of the voltage? 20. So what is the power delivered? 20 into 4, that is 80 watt. This answer is correct. It will deliver the 80 watt. Next question guys, without any delay. Then in the circuit shown in the figure, the magnitude of the current through R2. What is the magnitude of the current through the R2? And again that it depends upon what dependent source. Means what IISc Bangalore giving the question on what dependent sources, right? So that is the dependent sources because some students find difficulty. During what solving the question based on dependent sources. So this is the dependent source. You have to find the current through the R2 here. Means you have to find I here. Okay. Then simply apply the KCL at this point. Nodal equation and then find the voltage that we can assume that this is the VA. Find the VA. VA minus 8. 3 plus 5, 8 will give you the value of I. First of all, what we have to find? VA. VA upon 8. That will give the current through the R2 ohm. Okay. But how we can find a VA? Because there is one dependent source Vx. So what is the Vx in terms of VA? So this is the reference. So VA is the voltage across 3 and 5. So according to voltage division rule, 5 upon 3 plus 5 into VA. This is nothing but 5 by 8 VA. Vx is nothing but 5 by 8 VA. If it is the 5 by 8 VA, so what is the value of that? You can find 0.04 into 5 divided by 8 into VA. Right, when it is multiplied, it is what? 5 into 4, that is the 20.2. 0.2 divided by what? 8, that is the 0.1 divided by 4. At the end, you can solve VA. 0.1 divided by 4 or point, that is you can convert it into what? Further. Now, everything is over. Write down the KCL at this point. That apply the Kirchhoff's current law. You have already solved this. 0.2 upon 8. Then write down the KCL. VA. VA minus 60 divided by 5 plus VA divided by 8. VA divided by 8, and what is the incoming current? 0.2 by 8 VA. VA. Now can you solve this question everyone? Yes. अरे यार आपके कमेंट्स नहीं आ रहे, प्लीज बताइए. आप हो जाएगा सॉल्व ये आप लोगों से. चलिए अपना वर्चुअल कैलकुलेटर यूज कीजिए और बनाइए. व्हाट इज द आंसर फॉर दिस क्वेश्चन? What is the answer for this question? Tell me. Yes, please, everyone. Very easy. Once you will solve this value, you will get the VA is equal to 40. 40 divided by 8. So what is the current through that? 5 ampere. 5 ampere is the answer for this question, guys. Okay. So this is the part of this question. Next one. In the given circuit, each resistor has value equal to 1 ohm. Each resistor have value equal to 1 ohm. What is the equivalent resistance across the terminal A and B? You have to find the equivalent resistor across A and B. Okay. All resistors are of what? Equal values. So simply you can apply what? Delta to star and then what? Star to delta conversion here. Okay. So what is the method here and what is the answer then? Then this is a question of 2 marks in GATE 2016. So this is a conversion. Simply here, if remember, new students, please watch that. If there is a delta and every resistor is of equal value, then you can convert it into star like this. This is R, this is R, this is R. Let this is the terminal A, B and what C. Then this resistor will become R by 3. This resistor will become R by 3. R by 3 means value of the resistance decreases. So similarly, when this delta is converted into star, then here 3 resistors and all the resistors are what? R by 3, R by 3, R by 3. That is 1 by 3 because the value of the resistors is 1. This one is converted into what? 1 by 3. Now you can remove this resistance. So when we are removing this resistor, just I can remove this. Now watch this. Okay. Now remove this. Sorry. This one. Okay, once it is removed, now this is 1, this is 1 by 3. This is 1, this is 1 by 3. This is 1, this is 1 by 3. This is the 4 by 3, this is the 4 by 3, this is the 4 by 3. And here we are having the resistance. Here we are having the resistance value here. Right? Now what is this? 4 by 3, 4 by 3, 4 by 3. Now we are having the star here. 4 by 3, 4 by 3, 4 by 3. When the 4 by 3, 4 by 3, 4 by 3 is converted into delta, then this is the value. So it is 3 times. So 4 by 3 into 3, it will become 4. So then again you can convert that star into a delta. Then finally you will get the diagram. Just I am giving you the diagram here. Then one resistor at this point, 1, 4, parallel to that star is converted, delta is converted into star, star is converted into delta. 1. And 4 parallel with 1, that is the 4 by 5, 4 by 5. This 4 by 5, 4 by 5 means 8 by 5, it is in series and that is parallel to what? 4 by 5. Now you can find the value, guys. Okay. So check my calculation, but that is the method. So you can finally get the answer for this question. 18 by what? 8 by what? 15. 8 by 15 is the answer for this question. Okay. So that is the simple use the concept of star and delta. So that is another important topic. Then guys, next one. In the figure shown, the current I is, where is the current I? This is the current I. What is the value of the current I? Well, it is a 2 marks question in 2016. Now, watch this diagram carefully. This node are same. Suppose you are choosing it as a reference node. So what is the voltage at this point? 0. What is the voltage at this point? 0. So what is the voltage at this point? 0. So what is the voltage at this point? It will become 8 volt. Now you have to find out only the voltage at this point V1. Why? Once it is known, you can find the current in this branch, you can find the current in this branch, you can find the current, so that you can find the value of what? I here. Value of I here. Okay. So how we can find the V1? Now watch this. In this question, simply V1, write down the KCL. So what is the voltage at this point? 8, because it is 0. It is 0. It is 0. V1 minus 8 upon 1. All resistors are 1. V1 by 1. V1 minus 8 by 1. V1 minus 8 divided by 1, this one V1 minus 8, we can change the position of this resistor. 8 volt नीचे 1 ऊपर आ गया ये, तो ये चेंज कर सकते हो. V1 minus 0 by 1, right? The 1 is common, and this is the 1, 2, 3, 4. 4 V1 is equal to 16. So what is the V1 is equal to 4 volt? Very easy. 4 volt. Now once you will get the 4 volt, then here what is the current? The current will move from higher voltage to lower voltage. So it is a 8 volt, it is a 4 volt. So what is the current? 8 minus 4 upon 1, that is the 1 ampere. That is in downward direction. What is the current here? V1 minus 0 upon 1, so 4 ampere. This current is 4 ampere. Now if you want to find the I2, what is the current here? Here the current is 1 ampere. Here current is 1 ampere. Definitely this current is what? 2 ampere. This current is 2 ampere because at this point 2 ampere is incoming, one is going this direction, one is going this in this direction. So total 2 ampere. So what is the current at this branch? 2. What is the incoming 4? Out of this 2 is moving here. So what is the value of this I? 2. What is the value of this I2? Arey, your comments are not visible. Yes or no? That is clear to you everyone? Tell me. Your comments are not visible to me. This is correct explanation or wrong? Okay, value of that we have to check. Okay, tell me everyone. First of all, check this and to first of all get the value of the V1 and then guys apply the value so that finally you can find the value of I. But remember, always watch this diagram from this point to this point. The voltage will remain same and you can choose it as a what reference here, right? When we are choosing it as a reference, then this is what 0, that's why I am saying that this is the 8 volt and this is what 4 volt, right? And that's why this is a 0, that's why I am saying that what will be the current moving in this direction. Okay, so apply the KCL in this direction, 4 minus 1, that is the 4 ampere in this direction, 4 ampere in this direction. Then what will be the current you can find in this branch, and this is the 8, you can find the current here. Okay, so Prabhat, are you getting the what is the method to solve? Please, you can do the calculation here. Just I am giving you the method and then you can find the value of this question. Okay, so that is the way, in this way we can solve this question. So what about this question? We have to apply the KCL in one point only, at this point. At this point you have to apply the KCL. Now next question. Circuit theorems. Now this all basic questions are what it depends upon your command over what KCL, KVL, mesh analysis and nodal analysis. But now in circuit theorem you have to apply some concept. So just start with the theorems. That is what theorems. First question. In the network of the figure, the maximum power is delivered to R if its value is. Tell me what will be the value here. What is the answer for this question? In the network of figure, the maximum power is delivered to R if its value is 16 ohm, 40 by 3, 60 ohm and 20. So according to maximum power transfer theorem, first of all convert this diagram into what single voltage source and single resistor, that is called Thevenin's resistance. And according to maximum power transfer theorem, this RL should be equal to what? RTH. This RL should be equal to RTH, but only the value of the RL or R is asked, means simply you have to find the RTH. So what is the method to find the RTH? Now watch this. Simply, first of all, you want the value of R so that maximum power delivered to this. So remove this R, and connect a 1 volt battery here. connect a 1 volt battery here. That is I. Right? Now, what is the RTH? 1 by I. 1 by I, that is the RTH. Remember, this is the dependent source, this is the I1, this is I1. These two are the dependent, this is what? Current control current source. 0.5 I, and it depends upon the I1. We have to find the I. Now, watch this. This is a 1 volt here. Now, you can apply the KCL at this point. When I am applying the KCL at this point, what is the incoming current? 0.5 I. 0.5 I, that is the incoming current. What is the incoming current? I. I is also the incoming current. Is equal to, what is the outgoing current? 1 minus 0 by 20. 1 by 20. Plus, what is the outgoing current? You can say 1 minus 50 divided, or that is nothing but I1. That is what I1 is, the outgoing current. What is the value of I1? So, first of all, solve this. This will become I is equal to 1 by 20 plus 0.5 I1. Now, from the diagram, what is the I1? This is 1 minus 50 divided by 40. I1 will become 1 minus 50. 1, voltage 1, or what is the rule here? Normally what we are doing, just silly mistakes. So what is the rule here? All active sources, all independent active sources should act as what? 0. Right? If suppose you are not making it 0, then you are going to get the wrong answer. So that is the general mistakes in exam. Always make all independent sources, that is if it is voltage source, make it what? 0. Now what is the I1? 1 minus 0 divided by what? 40. 1 minus 0 divided by 40. That is 1 by 40. This is the value of I1. Now put here. So you will get I is equal to 1 by 20 plus 0.5 divided by 40. That is nothing but 1 by 80. So you will get 5 by 80. What is the 1 by I? That is the 16 ohm. Answer for this question is 16 ohm. 16 ohm. First one. Next question. So this is a simple Thevenin's resistance you have to find with the help of 1 volt battery. We have to apply the external source so that we can find the results here. Next question. Now, in the circuit shown in the figure, the maximum power, again that is what is the question? Maximum power delivered to the resistor in 2016. And that was the question in what? 2002. 2008 there was no question from this theorem. But 2016 again there was a question on theorem. Again question on what? Same theorem, that is what? Maximum power transfer theorem, guys. Okay. So what is the answer here? We have to find then. Tell me what is the answer. In the circuit shown in the figure, the maximum power delivered to the resistor R is. Where is the R? Yes. Maximum power delivered. Then you have to find, first of all, R is equal to what? RTH. The maximum power is given by VTH square by 4 RTH. That is the formula. VTH square by 4 RTH. Watch this question. First of all, remove this. Remove this. Okay. Then find the open circuit voltage here. This is called Thevenin's voltage. So what is the Thevenin's voltage? This is the 100 V0. So what is the V0 from this? V0 is nothing but 2 by 3 plus 2 into 5. That is 2 volt. So this 100 V0 will become 200 volt. What is the VOC? VOC will become 40 upon 10 plus 40 into what? 200. That is the 200 divided by 50, 160 volt. 160 volt is the Thevenin's voltage. Now what is the RTH? To find the RTH, first of all you have to make the 5 volt 0. 5 volt 0, right? So you have to make it 0. It will act as short circuit. And remove the R means make it open circuit. Make it open circuit. Now guys, no need to apply. No doubt there is a dependent source, but watch this diagram. No need to apply the 1 volt source here. Because when we are making the 5 volt 0, what is the V0? Because it depends upon the 5 volt, V0 will become 0. Once the V0 will become 0, what about this voltage source? It depends upon the V0, that's why this will become 0. This will act as short circuit. So 40 kilo ohm parallel with 10 kilo ohm. So what is the RTH? What is the RTH across this? 40 parallel with 10. 40 parallel with 10 means 400 divided by 50. That is nothing but 8 kilo ohm. 8 kilo ohm is the RTH. Now what is the power here? The maximum power is given by VTH square by RTH, 4 RTH. This is according to maximum power transfer theorem. Directly you can apply the formula. What is the VTH? 160 square, 160 divided by 4 into RTH, 8 kilo ohm, 8000 ohm. This is cancel out and that is 5 and this is 4. 4 divided by 5, that is nothing but 0.8 watt. 0.8 watt is the maximum power transfer to the load. So that depends upon the maximum power. You have to get the command over what? Thevenin's theorem. Then you can solve this type of questions. This is in what? GATE 2016 2 marks question, and very easy question. This type of network is called what? 2-port network, where this is independent. Input port is independent, output port is independent. We are connecting with the help of dependent sources, but input separated from the output. Then it will become very easy to solve this type of questions. Sir, I should be because of the dependent sources across a new network. Which one? It should be. Which one means which one? Then next question. In the circuit shown below, Vs is constant voltage source. Vs, where is the Vs? It is a Vs constant voltage source. And IL is the constant current load. The value of IL that maximizes the power absorbed by the constant load. That was the 1 mark question only. Right? Aragyadeep, what you want to ask? Then this is a 1 mark question. Vs is a constant current source, R is connected, what should be the value of IL? So it is a tricky question, but there are 2 ways to solve this one. What is the way? First, quickly we will solve. First, according to maximum power transfer theorem, if this is Vs, if this is R, so this is a load current. So what should be the load resistance? Load resistance should be nothing but RTH. So it should be equal to R. What will be the current here? What is the load current? Directly you can say load current will become Vs by what? 2R. Vs by what? 2R. So directly you can relate an answer is what? Vs by 2R according to maximum power transfer theorem, guys. Okay, this is the 2R. So this is the Vs by 2R. Directly you can give the answer. Or suppose that is, if suppose you want to check, sir, how we can find it, then try to understand. This current will flow like this. So what is the drop here? IL into R. So what is the voltage across this current source? Vs minus IL into R. Right. What is the drop across this ILR? So Vs minus that drop will give the voltage across the load. What is the voltage across the load? Vs minus IL into R. What is the power delivered to the load? VL into IL. Now you can say Vs minus ILR into what? IL. Now this is the power delivered to the load. You can multiply it. Then it will become VL is equal to what? Vs IL minus IL square into R. That is the power delivered to the load. Now which one is variable here? IL is the variable. So IL, what is the value of IL so that it will deliver the maximum power? Differentiate it with respect to IL. dPL by DIL. When I am differentiating this equation, this will become Vs and this will become what? 2 times of ILR. Equate it to 0 because we want to find the value of IL. So what is the, when we are equating, what is the IL? Vs by 2R. Again we are getting the same answer. And to find the maximum power, put the value of IL here. You will get the maximum power. So that is the method. So again we are getting the same answer. Okay. I think now it is clear. Right. Now, next one. Up, that is already we have solved what question on what theorem. So these are the questions that is from the electronics branch. Okay. So I think you get the idea how much questions from the basics. So means in IISc Bangalore, balanced paper, question from the basics of the network. Then what? Questions from the theorems, and in theorems normally maximum power transfer theorem, Thevenin's theorem, Norton's theorem. These are the very, very important one. Now steady state analysis of what? Sinusoidal signal. Are you ready to solve some questions? Steady state analysis. First question. The Thevenin's, again that is the Thevenin's equivalent. Thevenin's equivalent impedance ZTH between the nodes P and Q in the following circuit. Because the theorem, same theorem we can apply in case of what? Steady state analysis of sinusoidal signal here. So what is the, it is in the form of that Laplace transform, that is S. 1 Henry it is given, 1 ohm is given, 1 capacitor is given, 1 ohm it is given. It is a very, very, very easy question, guys. In 2002, what is the Thevenin's impedance across that open terminal? This is the P and Q. This is P and that is what? Q. Now, for Thevenin's, first of all, this current source will act as open circuit. To make it open circuit, remove this, because all independent active source should 0. Remove this. What about the current source? It should act as what? Short circuit. So this will act as, voltage source will act as short circuit, make it 0. Now what is the impedance because of the inductor SL? It will become S because the L is 1. What is the impedance because of the capacitor? 1 by SC. What is the value of C? 1. So that's why it will become 1 by S. Now across P and Q, this S plus 1 and this is 1 plus 1 by S. They are in parallel. So what is the ZTH? S plus 1 parallel with what? 1 plus 1 by S. Parallel with what? 1 plus 1 by S. Now what? Find a parallel combination. S plus 1 into what? 1 plus 1 by S upon what? S plus 1 plus of what? 1 plus 1 by S. So you can solve it. When it is multiplied, this is the S plus 1 upon what? S. Then this will become, because that is, you have to take the S as a LCM, so it will become S square plus 1, and then this is plus S, this is again multiplied S plus 1 divided by S. This S cancel, and this is also S square plus 2S plus 1, so that is nothing but S plus 1 square upon S plus 1 square. What is the answer? 1. Answer for this is what? 1. So what is the Thevenin's impedance across P and Q? 1. A option. And guys, watch this. It is a 2 marks question. 2 mark question. Okay, in 2008. But now we will get same type of questions. But what about the marks? It may be of 1 mark question. Right? Then this is in 2008. So tell me guys, up to this point, is there any extraordinary questions? Any extraordinary questions here? Normal questions, no doubt 1 or 2 tricky questions, but you can solve this. So that will give you the confidence. Now watch this. This is the sinusoidal signal is connected here. This is the 10 sin omega t, 10 sin of t. 10 sin of t signal is connected here. What is asked? An AC voltage source 10 sin t volt is applied to the following network. Assume that R1 is 3 kilo ohm, R2 is 6 kilo ohm, R3 is 9 kilo ohm. All the values are different. The diode is ideal. This diode is connected here. It is just like a half wave rectifier. RMS current through the diode is. What is the RMS value of the current through the diode? That was the tricky question in what? GATE 2016. That is by IISc Bangalore. So how we can solve this? Now watch this question. One minute. First of all, if that is a cube, that this is the cube. Okay, this is the diagonally opposite points. Just I am connecting a battery, any value, whether it is a DC or AC. Then remember, if these three resistors are same, these three resistors, if you are giving the current, it is divided into three parts: I by 3, I by 3, I by 3. Because it is a symmetrical diagram, I by 3, I by 3, I by 3. Now what is the resistance value? In this question, R1, R2, this is the R1, this R1, this R1, this R1 are equal. Now after that, at this node, this R2 and this R2 is equal. After this node, this R2 and this R2 are equal. After this node, this R2 and this R2 are equal. So again that current is divided into what? This I by 3 is divided into two parts, I by 6, I by 6. Again it is divided into two parts, I by 6, I by 6. Again it is divided into two parts, I by 6, I by 6. Again we can add these two current, I by 3, I by 3. And what is this current? Again it will become I by 3. And finally you will get the current I. So that is the called distribution of current in this diagram. So same logic we are going to apply here, and you will get the current, what is the total current, and then we will apply what? KVL here. KVL to find the equivalent resistance here. Okay. Now watch this diagram carefully. Then this is I by 3. Then what is this? Already I have given I by 6, half. What is the current here? Again we are adding the I by 3. Because this is divided into I by 3, I by 3, I by 3. Then I by 2, I by 2, I by 6, and then finally this. Now you can apply the KVL from this point to this point. So first of all, you can assume any battery. Then what is the R equivalent? First of all, you can find the R equivalent of this circuit. It will become I by 3 into R1 plus I by 6 into R2 plus I by 3 into what? R3 is equal to V. That just I am giving one battery. Just first of all remove the diode and then give the battery of voltage V to find the resistance of this portion. Then what is the value of the R1? That is given in the numerical: 3 kilo ohm, 6 kilo ohm, 9 kilo ohm. 3 kilo ohm, 6 kilo ohm, 9 kilo ohm. Okay. You can put I common: 3 divided by 3, 6 divided by 6, 9 divided by 3 is equal to what? V. So what is the V by R? This is called R equivalent. V by I. 1 plus 1 plus 3, that is 5. Diagonally opposite the resistance of this network is what? 5 ohm. Now you have got the 5 ohm. What is the current? For positive half the diode is on. So for positive half, this is the 10 sine of omega t. So for positive half, the current is 10 sine of omega t divided by R equivalent, that is the 5, to 2 sine omega t. And for negative half, what will be the current? 0, because it is a rectifier. Then you will get this type of curve. And that is the integration of what? Analog and network. Now that is the curve. Okay, and what is the maximum value? 2. 2 sine of omega t, maximum value is what? 2. This is a half wave. What is asked here? What is the RMS value? So RMS value for half wave rectifier is Im by 2. Maximum value divided by 2. So tell me, I think this is clear to you, everyone. This question is clear to you. Okay. Okay. So that is the answer for half wave rectifier. Always remember IRMS is what? Im by 2 and IDC is equal to what? Im by pi. IDC is equal to Im by pi. Check calculation. And now again on RLC circuit, that is the steady state analysis of sinusoidal signal. The figure shows, and that is in 2016 electronics branch 1 mark question. The figure shows an RLC circuit with a sinusoidal current source. Where is the sinusoidal current source? This is the Im sin omega t. R is the 10 ohm, L is the 10 millihenry, C is the 10 microfarad, and sin omega t. At resonance means this is the at resonance. The IL and IR, IL divided by IR, that ratio is required. The ratio of the magnitude of the inductor current phasor and the resistor current phasor is. What is the inductor current and phasor and this one? Okay. So you can watch this diagram. In parallel, voltage will remain same. From this point to this point, voltage is same. Because in a parallel, the voltage will remain same. So you can write IR is equal to what? V by R. You can write IL is equal to what? V by ZL. V by ZL. So what is the IL by R? Divide the equation 2 divided by equation 1. When the 2 divided by 1, so you will get the R by ZL. R by ZL. What is this? R by J omega L, because the impedance is what? J omega L, because of the inductor. But only the magnitude is required. So IL by IR, that is nothing but R by omega L. Now what is the value of the omega? Because the circuit works in what? Resonance. So at resonance, what is the omega? Resonant frequency, it is given by 1 by root over LC. 1 by root over L and C. Now you can put the value 10 millihenry and 10 microfarad. 10 into 10 raised to power minus 3 into what? 10 into 10 raised to power minus 6. Right. So then this is what you can find the value of resonant frequency. Now tell me what is the value here? Are you getting any omega naught? And then put the value of omega and then put the value of what? 10 millihenry, and you can find the ratio of this. So this is the calculation. You can do the calculation and just I am giving you the answer. Right. You will get the answer 0.316. 0.316 here. So resonance frequency. Right, this is the question in 2016 ECE 1 mark question hai, only 1 mark. Okay then. Any doubt? So what will happen in resonance? Remember, first of all, voltage will remain same. So V by R, V by Z omega L, and what? V by what? ZC. You can find the IR, IL and IC, and then you can find also the ratio of that phasor. Second important thing, in a parallel resonance, this combination of inductor and capacitor will act as what? Open circuit. Capacitor and inductor will act as open circuit here. Now, next one. Watch this diagram. Are you doing your calculation by using the virtual calculator, everyone? No comments. Please give me the comments also. Okay. Now, in the RLC circuit shown in the figure, the input voltage is given by 2 cos of 200t plus 4 sin of 500t. The output voltage V0t is. Remember, this is a 100 microfarad capacitor. It is a 10 microfarad capacitor, 0.252 ohm that is given. And it is a 1 mark question only, but the circuit is what? Very complicated circuit. But remember, if you are using the concept that under series resonance or at series resonance frequency, this will act as what? Tell me, Ishwar. Combination of L and C will act as series combination of L and C will act as what? Short circuit. And then what about this one? Inductor and capacitor, parallel combination of inductor and capacitor under resonance will act as what? Open circuit. We will use this concept. So what is the frequency? This is nothing but 2 cos of omega 1t plus 4 sin of omega 2t. And remember, when we are having the signal with the two different frequencies, then definitely we have to apply what? Superposition theorem. We have to apply the superposition theorem here because we are having the two frequencies here. Now, first of all, that is the question, which theorem is applicable to superposition theorem when we are having the two different frequencies. The first frequency is what? 200 omega naught. Omega naught is what? 200. So we are applying the one signal 200. This is the value of omega. Now what is the frequency, resonance frequency for that? You can find 1 by root over LC. 0.25 into 100 microfarad, right? 100 microfarad, 10 raised to power minus 6. Okay, check what you are getting, right? This is the 25, or that is will become 10 to the power minus 6, 10 to the power minus 3, 5. Thousand by 5 means what? 200. And what is the frequency given? 200 means that series is under resonance. When the series is under resonance, it will act as short circuit. So you will get this type of diagram. This will act as short circuit. It doesn't matter what is the impedance connected here. What will be the output? Output is exactly replica of the input, first input. So in a time domain, you can convert it into frequency domain. The first output, because we are applying the superposition theorem, this will remain same, 2 cos of 200t. 2 cos of 200t. 200t. Now the second signal is what? 4 sin of 500t. For 4 sin of 500t, Vi2. What is the omega? 500. Now, what is the resonance frequency for this network? Resonance frequency for this network is root over 0.4, that is the value of the L, into what? 10 microfarad. 10 into 10 raised to power minus 6. 10 into 10, that will become what? 10 to the 4. And what is the root of the 4? 2 into 10 to the power minus 3. That will become 1000 by 2. No, calculator is not required here. 500. So what is the resonance frequency for this portion? 500. So under resonance, this will act as what? Open circuit. So once it will act as open circuit, remember, it doesn't matter what is the impedance here, because this will act as open circuit. This resistor is just floating. This is act as open circuit. So what is the output? Output is equal to what? Vi2. Vi2. So you will get the same output, 4 sin of 500t. So we are applying the superposition theorem. Why? Because we are having the two different frequencies, right? 200 radian per second and 500 radian per second, right? So now add these two answers. 4 sine of 500t is the answer output for this. What is the output? This will remain for first case 2 cos of 200t, for second case 4 sine of 500t, and in a time domain we are adding, and that's why we are getting the B answer for this question. It was the tricky question, but only 1 mark question in 2016. Okay, that is from the IISc Bangalore. The next one. Now guys, transient analysis. Transient analysis. Are you ready? Quickly we are solve that question from the transient. In the figure, the switch was closed for a long time. Where is the switch? This is the switch, closed for a long time, and before opening at t equal to 0, means exactly at t equal to 0 switch was open. The voltage Vx, tell me what is the answer, 25, 50, minus 50 or 0 volt. Voltage Vx across this resistor. Now this is a question on transient. Remember, DC current is connected here, DC. For DC, under steady state, inductor acts as short circuit. Capacitor acts as what? Open circuit. When the switch was closed, for long time, and finally at t equal to 0 it is open, so what will happen? Exactly at t equal to 0 negative, just before switch is moved from this position to this position, this is called t equal to 0 negative, because exactly at t equal to 0 we are going to opening the switch, means for t less than 0 switch was closed, for t greater than 0 switch is open. Exactly this point, this is called 0 negative, and since the switch is closed for long time, at this point just before switching action, circuit is under steady state. When the circuit is under steady state, this inductor will act as short circuit. So if this inductor will act as short circuit, switch is also closed, then this inductor is short circuited, this switch is closed, everything is short circuited. What about this 2.5 ampere? 2.5 ampere will flow through the inductor. 2.5 ampere will flow through the inductor. Remember, inductor does not allow sudden change of current. I0 negative is equal to I0 positive is equal to what? 2.5 ampere. So this is called initial condition. Exactly at this point 0 plus, it is called initial condition, or at this point it is called steady state with the previous condition. Now once you will get the 2.5, what is asked, what is the voltage Vx at t equal to 0 plus? To draw the diagram at 0 plus, the switch is open now. This is the closed loop. So 2.5 ampere will flow through the 20 ohm. Now this is the second circuit, and that is the 20 ohm. This is plus, this is minus. Inductor does not allow sudden change. So what is the current through the inductor? 2.5. So this same current will flow through what? This resistor, 2.5. This is the 2.5. But it is moving in opposite direction. So what will be the drop? 2.5 into 20. That is the 50 volt. This is plus, this is minus. But what is the polarity of the Vx? Opposite. And that's why Vx is what? Minus 50 volt. Vx is what? Minus 50 volt. Opposite polarity. Current enter through this plus and minus, and Vx is opposite. Minus 50 is the answer for this question. Okay. Then next one. In the following circuit, the switch S is closed at t equal to 0. Again, transient. Right, in 2008, 1 mark question only. In this case, the switch is closed at t equal to 0. The rate of change of the current di by dt exactly at 0 plus, means again the question on what? Initial condition. Question on initial condition. Tell me what will be the answer. Initially the switch was open. In this question the switch is open initially. So what is the current through the inductor? 0. Circuit is unenergized. If the initial current is 0, then final current, initially I0 is what? 0. Current through the inductor is 0. An inductor does not allow sudden change of what? Current, remember. But you have to find the di by dt. What is the rate of change of the current through the inductor? Okay. Then that is the answer, 0, Rs Is by L, R plus Rs by L, infinite. Now watch this. When we are talking about the inductor, inductor does not allow sudden change of current. When we are closing the switch is closed, then what will happen? Initially, no doubt, inductor will not allow the current. So what is the I0? But what about this current? This current will pass through the Rs. It will develop a voltage here. What is the voltage here? IS into Rs. IS into Rs. And now there is a voltage across the inductor. And what is the voltage across the resistor? 0. So can you write the KVL so that we can say VL is equal to V? So right, so directly it is parallel, or directly you can say minus V plus VL, because there is no drop across R. Initially I is 0. Exactly the diagram at 0 plus is equal to 0. What is the VL is equal to V? IS RS. Exactly at t equal to 0. Now what is the VL? Voltage across the inductor is given by di by dt at 0 plus. That is IS RS. What is the di by dt 0 plus? IS RS upon what? L. IS RS upon L, that is the value. Which answer is correct? This one. IS RS upon L. Very simple question. तो देखिए ये है, दिस इज द ऑन फ्रॉम व्हाट IISc बैंगलोर. तो आपको ये कॉन्फिडेंस देगा कि कैसे हमको सॉल्व करना है. ओके, देन नेक्स्ट वन. Then this is the next question. Okay, now RLC circuit, second order circuit, again transient on second order circuit. And what is the written? Del T, impulse function is applied here. Impulse function means we have to apply Laplace transform. With the help of Laplace you can solve the following series RLC circuit with zero initial condition. Means current through the inductor is 0, voltage across the capacitor is 0, current through the inductor 0. What is the voltage across the capacitor? 0. That is given in the question, initial condition. And in capacitor and inductor is excited by a unit impulse function del t. For t greater than 0, the output voltage VCT. It is a linked question. It is what? Linked question. There are two questions on the same data. Once it is asked what is the voltage across the capacitor, in same question what is asked, what is the voltage across the resistor. One question 2 marks, next question is also 2 marks, means total 4 marks question. This one. So how to find? So this is the answer it is given, means we have to apply the Laplace, then Laplace inverse. So what is the VC here? Del t it is given. Then watch this diagram. Because all the initial conditions are 0, all the initial conditions are 0. So what is the del t? The Laplace of the del t is 1. Inductor is represented by in Laplace SL. So what is the SL? S. Because L is 1. Resistor will remain resistor. It is the 1 by CS. What is the value of C? 1 farad. So that's why it will become 1 by S. So this is in a frequency domain. S, 1, 1 by S, and this is what? 1. Now, what is the voltage across the capacitor? Then VCS. We can say the VCS according to voltage division rule, it will become 1 by S, that is the impedance, upon what? S plus 1 by S. S plus 1 by S into what? VS. And what is the VS? 1 here. VS is 1 here. So this is the VCS. Now you can write 1 by S upon S square plus S plus 1 by S. This SS cancel. What is the VCS? 1 upon S square plus S plus 1. Okay. Now if you want to find the Laplace inverse, so please arrange it in a perfect square. Then what is the method here? VCS is equal to, you can write here S plus 1 the whole square, S plus 1 by 2 the whole square. So it will give what? S square plus S plus 1 by 4, right? You have to subtract 1 by 4 plus 1. New student, please watch this. In this way we can write, we can convert this into square term. Then it will become S plus 1 by 2 square plus what? 3 by 4. Now, once you will get this, then you can write VCS is equal to S plus 1 by 2 the square plus 3 by 4, right? That is the 3 by 4. Then 1 upon S plus 1 by 2 the square plus root 3 by 2 the square, we can write. Now, multiply it by what? Root 3 by 2 and divide it by what? Root 3 by 2. When I multiply by root 3 by 2 and divided by what? Root 2 by root 3. What is this? Root 3 by 2 upon S plus 1 by 2 the square. So what is the Laplace inverse of this? So remember, omega upon S plus A plus omega square. What is the Laplace inverse of this? Laplace inverse of this is e raised to power minus at sine of omega t. E raised to power minus at sine of omega t. Find the value. So 2 by root 3 is common here. And then this is the a, so it will become minus 1 by 2t. And then sine of root 3 by 2 into t. That is omega. That is the answer for this question. Answer for this question. Watch which answer is correct. Options are given. 2 by root 3 e raised to power minus d is the correct answer. D is the correct answer for this question. So simple use of Laplace and then find the Laplace inverse very quickly. This is the answer D. 2 mark question. Now, so I think no doubt here, to apply voltage division rule and then you can find. Similar question where this is a linked question, 4 marks. Now this time same RLC circuit excited by the unit impulse function, voltage across the resistor R. This time you have to find the voltage across the resistor R. Again we have to apply the voltage division rule. What is the voltage division rule? This is the S. First of all convert it into frequency domain diagram, then this will become 1, this will become S, SL means what? S, this is remain 1, this is the 1 by S, because the C is 1 by SC. Then what is the voltage across the R? According to voltage divide rule, 1 divided by S plus 1 by S into what? 1, because the voltage is 1. Now what is the VR? That is S upon, this will S square plus S plus 1. Now you can write VR is equal to S upon, already I have given S plus 1 by 2 the whole square plus root 3 by 2 square. Yes, I have already solved this question in previous question. In this way you can find S plus 1 by 2 the square plus root 3 by 2 the square. You can check, you will get the same value there. Then when it is over, then because in numerator we are having the S, so how we can solve? Again you have to use the concept of what? Laplace. Then VR is equal to S upon S plus 1 by 2 square plus root 3 by 2 square. Then you can write in numerator S plus 1 by 2. If you are writing the 1 by 2, then you have to subtract 1 by 2 upon this value. Okay, you have to add and then you have to subtract 1 by 2. Then it will become s plus 1 by 2 upon s plus 1 by 2 square plus root 3 by 2 square. First term minus 1 by 2. Now what this? If it is in denominator, minus 1 by 2, that is in denominator, s plus 1 by 2 the square plus root 3 by 2. So in numerator this is required for standard format. So it is multiplied by the root 3 by 2 and it is divided by the root 3 by 2. 2 by root 3. So these two cancel out. And this is the standard formula. What is the Laplace inverse of this? E raised to power minus 1 by 2t cos of omega t. And here minus these two cancel, 1 by root 3, 1 by root 3 sine of root 3 by, that is the omega upon s plus a the whole square omega square, sine of e raised to power minus 1 by 2t sine of root 3 by 2 t. Now you can take e raised to power minus 1 by 2t common and that will be the answer for your question. This is the second answer. This is the voltage across the R. Right? So which answer is correct now? देखिए e raised to power minus 1 by 2t common, cos of root 3 by t, ठीक, minus 1 by root 3 sine of root 3 t by 2. This is the answer. Very simple use of Laplace, right? Remember, capacitor does not allow sudden change of what? Voltage. But here the capacitor will allow the sudden change of voltage. Why? Why the capacitor will allow the sudden? Because we are giving the impulsive signal, right? So yes, you can find the value. Okay then. You can check whether the capacitor will allow the sudden change of voltage or inductor will allow the sudden change of current in this diagram exactly at t equal to what? 0. So exactly at t equal to 0, watch this diagram. Exactly at t equal to 0, what is the current here? What is the voltage across the capacitor? 0. What is the voltage across the capacitor? 0. Means capacitor does not allow sudden change of voltage. But inductor will allow the sudden change of current. Why? Because we are giving the impulsive voltage here. We are providing the impulsive voltage. So remember two things with this diagram. First thing, normally inductor does not allow sudden change of current, right? But when we are giving the impulsive current, because what is the IL is equal to 1 by L integral of V dt. When we are giving the impulsive voltage here, impulsive or infinite voltage, then it will allow the sudden change of current. In this diagram, we are providing the impulsive voltage. Similarly, what about the capacitor? Vc0 negative is equal to what? Vc0 positive. Capacitor does not allow sudden change of voltage, right? But if we are giving the impulsive current, because what is the voltage across the capacitor? 1 by C integral of I dt. For finite current it will not allow, but if you are giving the impulsive current, then definitely it will allow the sudden change of voltage capacitor. You can check with this concept here. Now next one. Next question. Now tell me, what is the answer for this one? What is the answer for this one? The switch has been in a position 1 for long time. This is the switch 1 for long time. And then abruptly changes to the position 2 at t equal to 0. If the time t in the second, the capacitor voltage Vc for t greater than 0 is given by. In 2016 ECE 1 mark question. If the switch is in a long time, then circuit will reach to what? Steady state. Now this is connected here. Then again the initial condition will start and we have to find the equation for this portion. So how we can solve this question? So first of all, you have to find the initial current. To remove this circuit. Remove this circuit. And now remember, the capacitor will act as what? Open circuit. capacitor will act as open circuit here. This is the diagram exactly at t equal to 0 negative. For long time this is closed, that's why circuit is under steady state. This is the DC. For DC, capacitor act as open circuit. So according to voltage division rule, what is the VC0 negative? And that is equal to VC0 positive. This is equal to 2 divided by 3 plus 2 into 10. That is the 4 volt. What is the initial voltage across the capacitor? 4 volt. Because exactly at t equal to 0 negative, circuit is under steady state, guys. Here, try to solve the question. Give me the feedback that everything is going fine. Everyone use your copy, pen and calculator and try to solve this type of questions. 4 volt. Once you will get the 4 volt, okay. Now, exactly at t equal to 0, switch is closed here. So, you can remove this portion. You can remove this portion. Okay, remove this portion. Now, once it is removed, then guys, this one, 5 ampere current source, 2 ohm, 2 ohm, 4 ohm, and this is the VC. What is remember, once the current and resistors are connected in parallel, series, no need to consider it, remove it. No need to consider it. This is simply what is the current enter into this network? 5 ampere. Enter into this network is what? 5 ampere. Because that is connected in series. Now, under steady state, again this capacitor will act as open circuit. Exactly at t equal to infinite, this capacitor will act as open circuit. Then this 5 ampere current will flow through this 2 ohm resistor. And this will act as open circuit. So what is the final voltage across the capacitor? Final voltage across the capacitor is 5 into 2, that is the 10 volt. Or exactly at t equal to infinite, there is no current through the 4 ohm resistor because the capacitor will act as open circuit. And the complete current will pass through this 2 ohm resistor. Okay. What will be the voltage across the capacitor? 5 into 2, that is the 10 volt. So final value we have, initial value we have, what is the time constant of the circuit? Now to find the time constant we can find RTH into C. What is the RTH? The Thevenin's voltage across the C. So current source will act as open circuit. So what is the Thevenin's resistance across C? So first of all, remove the C. 4 ohm, that is 2 ohm. So this is 2, this is 4, and this current source will act as open circuit. This is the floating resistor, no need to consider it. 4 and 2 are in series. So what is the RTH across the C? RTH across the C is 6 ohm. What is the time constant? This is the 0.1 farad. So 6 into 0.1, that is the 0.6 is the time constant. Now you have the initial value, you have the final value, you have the time constant, that is the 0.6. What is the formula? General formula. General formula, then you can check the answer directly. V is equal to, Vt is equal to V final minus V final minus V initial e raised to power minus t by tau. What is the final value? 10 volt. What is the final value? 10 volt. What is the initial value? 4 volt. What is the t divided by 0.6? T divided by 0.6. So which answer is correct? That one. 10 minus 6 e raised to power minus t by 0.6. D. D is the correct answer for this question. So first of all find the initial value, then find the equation. And always remember, if in any numerical, if the time constant is asked, then time constant for this portion, always for t greater than or equal to 0. Always we have to find the time constant for this. And when the for long term the switch is closed, then the capacitor will act as open circuit. Next one. So this is the D. Any doubt up to this point, guys? And then you can join what? Our Telegram channel, that is the BYJU'S exam prep, GATE, EC, EE, instrumentation preparation, right? And you can join our app. You can go for what? Scholarship test also, right? This Sunday we are going to conduct the scholarship test, and you can also join my Telegram channel for PDF of this session. Electronics by Sanjay Rathi. Okay. Next one. Next question. Now, one diode is connected here in 2016 ECE 2 marks question. The switch S in the circuit shown has been closed for a long time, right? Switch S in the circuit has been closed for a long time. It is opened at time t equal to 0 and the remain open after that. Assume that the diode has a zero reverse current. Diode has a zero reverse current and zero forward voltage drop. Means ideal diode. Ideal diode. The steady state magnitude of the capacitor voltage in volts. Steady state value magnitude of the capacitor voltage. Steady state value. A diode is connected here. Okay. Now, first of all, guys, when this 10 volt battery is connected, because the positive polarity here, negative here, this diode is off. Initially it is off. When the switch was closed, it is off. Now you can say the switch is closed. Right, watch this. When switch is closed, this diode is off. Then complete current will pass through the inductor. So what is the initial current through the inductor? This is the exactly at t equal to 0 negative. Inductor will act as short circuit. 10 divided by 1, that is the 10 ampere. This is the current through the inductor initially. Okay. Then this is the inductor, this is the capacitor. Now the switch is open. You can remove the switch. You can remove the switch. Now you have the initial current through the inductor. Once the initial current you have, then you can replace the inductor. Always remember, inductor is replaced like this. What is the value inductance? SL. In Laplace transform. In frequency domain, it is a SL. And what is here? Initial current through the inductor divided by what? S. Now this is the representation of the inductor in frequency domain. SL parallel with what? I naught. I naught is the initial current through the inductor. We have the value 10 upon S. You can convert this current source into what? Voltage source. So this is multiplied with that. So this is the voltage source. It is converted into impedance and one voltage source also. What is the value of the voltage source? Right, this is minus, this is plus. So this is minus, this is plus. SL multiplied with this, S cancel, Li naught. Li naught, and this will remain SL. So this is the source transformation. So this is the two representation in frequency domain. So what is the value of the L? 1 millihenry, and what is the value of the current? 10. So it will become 1 millihenry 10 raised to power minus 3 into 10, that is nothing but 10 raised to power minus 2. SL, it will become 10 raised to power minus 3 into S. And then what is about the capacitor? Capacitor is represented by 1 by SC. What is the initial voltage across the capacitor? 0. Then this is simply represented by 1 by SC. 1 by SC. Then watch the polarity plus minus. So 1 by SC means 1, this is the 10 microfarad. So it will become 1 by S into 10 raised to power minus 6. That will become what? 10 raised to power 5 upon what? S. 10 raised to power upon 5 upon S. That is the value of the capacitor. Okay. Now we have the value, this is the inductor, representation of the inductor. And let initially that the diode, we are not assuming the diode, right? So what, with the help of Laplace, you can find the value. We can find the equation. What is the equation here? Watch this. Now, this inductor is replaced by a current source. This is the voltage source, SL. Already I have given the value of SL. This is the 10 raised to power minus 3S. Ten raised to power minus 3S, 10 raised to power minus 2. Then this capacitor, is replaced by 10 to the power 5 by S. Okay, now then you have to find out voltage across the capacitor, okay, VC. Okay, then you can find value of the current here, because in this direction the diode will allow the current to write down the equation in this direction, in this loop. So when we are applying the IS, this is called Laplace IS. This is the plus minus, this is the plus minus, and now you can write the KCL. It is multiplied by IS into 10 raised to power 5 by S plus 10 raised to power minus 3 SIS minus 10 to the power minus 2 is equal to what? 0. Then you can take IS as a common. It will become 10 to the power 5 by S plus 10 to the power minus 3 S is equal to 10 to the power minus 2. Okay, then you can convert it into points also. Then what is the IS is equal to? Or at the end you can also put the value of the C and S. Then it will become 10 to the power minus 2 upon 10 to the power 5 divided by S plus 10 to the power minus 3. Okay, then you can multiply it. Then this will become 10 to the power minus 2s upon, this will become 10 to the power 5 plus 10 to the power minus 3s square. Now from this you can take 10 to the power minus 3 as a common. When you are getting the 10 to the 5 minus 3 as a common, you will get IS is equal to 10 to the power minus 3, 10 to the power minus 2. In the numerator it will become 10s. You can take 10 to the power minus 3 as a common. It will become 10 to the power 8 S square plus 10 to the power 8. S square plus 10 to the power 8. And numerator 10s. This is the value of IS, Laplace. Then once you will get the IS, you can check my calculation also. 10s divided by S square plus 10 to the power 4 square. 10 to the power 4 square here. Now guys, it is a S. So you can directly write the what is the IT, Laplace inverse. 10 you can take common. Then it will become what? Laplace inverse of that, because S upon S square plus A square means it is a cos of omega t 10 to the power 4t. Cos of omega t 10 to the power 4t. That is the value of current. That is the value of what? Current. So when you are plotting the current, you will get this type of cos. Cos signal. Right? What is this? What is the magnitude? 10, 0. But this is the 0. This is what? Pi by 4. Okay. Then this is a cycle from this is 0. This is up to what? Pi. 2 pi. This is pi. And this is what? Pi by 4. And this is what? 3 pi by 2. So what I want to say here, that from 0 to pi by 4, the current, diode will allow the current. When the current is positive, diode will allow. But when the current is negative, diode will not allow, because diode is connected in the diagram. Diode is connected in the diagram. Diode is connected. So we are finding the current here. When this is the current, when this is positive, it will allow, but when it is the current is negative, it will not allow. So for this portion to this portion, the current is allowed, but for this portion not allowed. Again for this portion it is allowed. This is the cos omega t. This is the cos. Now when there is a current, then there will be the drop across this. See, so what is the impedance? So you can say what is the VCS? What is the impedance of that? 10 to the power 5 by S. 10 to the power 5 by S, right? and then you can find the voltage across the inductor 10 to the power 5 by S, and what is this? 10S upon S square plus 10 to the power 8S. Last question. Okay then. Into current 10S, just I am writing in the Laplace, VCS IS into voltage impedance of this 10 to the power 5 by S. IS multiplied with this 10 to the power 5 by S multiplied with the 10S upon S square plus 10 to the power 4. This S is cancelled, and that will become what? 10 to the power 6 upon S square plus 10 to the power 4 the whole square. Or you can write 10 to the power 6 in two parts. 100 into 10 to the power 4. So omega upon S square plus omega square. What is this? Omega upon S square plus omega square. That is nothing but when we are taking the Laplace inverse of this, it will become 100 sine of 10 to the power 40. Sine of omega t. That is the Laplace inverse of that. I am finding the Laplace inverse of this. 100 upon S square plus omega square. So sine of omega t, 100 sine of that. Right? Now, once the current reached to what? Maximum. Right? And at that time, what is the voltage across that capacitor? Maximum, that is 100. So what is the magnitude of that? What is the maximum magnitude? Because once the capacitor charge up to 100, what about the negative half? Negative half, there is no current, circuit acts as open circuit, and that's why the capacitor will not discharge during negative half. Capacitor will not discharge during negative half, and that's why, what is the question asked here? Watch this. The steady state magnitude of the capacitor voltage, that is 100. That is what? 100 volt. Because in this direction the capacitor will charge, but in opposite direction there is no current. So what is the highest voltage here? 100 volt. What is the highest voltage? 100 volt. Okay, there is no path for discharging. So this is about this question. Okay, so stay tuned with me, subscribe the channel. Tomorrow we will solve the remaining question in network part 2. Just I am giving you the in 2016 two-port network and other topics we will cover, and the question from the electrical branch we will cover. All the questions from what? Electrical branch. Today we have solved all the questions from, almost all the questions from electronics branch. And remaining question we will solve tomorrow, and same time is Monday 7 p.m. 7 to 9 p.m. we will solve. Okay, so stay tuned with me, subscribe the channel and like the session so that you will get the notification about my sessions. Okay then. So guys, again remember, you have the scholarship test on 27th of August. Window will be open for 9 a.m. to 9 p.m. You can register now, and that is the opportunity for you. And after giving the scholarship test, if you want to know about how to utilize the next 150 days, next 5 months, then roadmap to be a gate topper in just 5 months. So live interactive workshop I am going to take, and that is a live on 29th of August at 7:30 p.m. sharp. Okay. So this is all about this session, guys. And this is a course, right, on our platform on BYJU'S exam prep. This is the course for electronics branch, and that is the course for what? Electrical branch. We are going to start the crash course for you. The complete revision in last 4 months with live classes, recorded lectures, practice session, practice quizzes and what? Mock test. क्या चीज चाहिए? 5 important parameters. तो देखो पूरे के पूरे पांचों cover होंगे, and within 4 months you will cover the complete syllabus and you can get the top rank, guys. Okay. Or all faculty members are highly qualified and highly experienced, then you can join now, guys. Okay, then thank you for attending the session. Then this is the electronics by Sanjay Rathi. You can join my Telegram channel if you want the PDF of my session. So this is the electronics by Sanjay Rathi. I will upload the PDF of this session on my Telegram channel. Okay, then thank you very much for attending the session. You are on BYJU'S exam prep. Like the session, subscribe our channel, guys.